Hello, welcome once again. In this video series we will see what is Niagara and how to use the Niagara system for creating excellent VFX. Niagara is Unreal Engine's next generation VFX system. With Niagara, the technical artist has the ability to create additional functionality on their own, without the assistance of a programmer. The Niagara VFX system is one of two tools we can use to create visual effects inside Unreal Engine 4. Before Niagara, the primary way to create and edit visual effects in Unreal Engine was to use Cascade. We have made tutorial series for that also, and the link has been provided in the description. While Niagara has many of the same of particle manipulation methods that Cascade offers, the way we interact and build visual effects with Niagara is vastly different. Before we can begin to create visual effects using Niagara, we will need to enable it via the plugins menu. In this video, we go over what needs to be done in our Unreal Engine project so that we can use Niagara. Please like this video if you find it helpful and informative, and subscribe to our channel for newer updates and game development tutorials. So let's start. The Cascade to Niagara Converter plugin is a utility designed to convert any of our existing Cascade Particle Systems assets into equivalent Niagara Systems assets. The plugin includes a blueprint function library to generate both Niagara Emitter and Niagara System assets. To enable the Cascade to Niagara Converter plugin for our project, we need to perform the following steps. First, navigate to Edit and then to Plugins in the main menu to open the Plugins browser tab. Second, from the built-in category side menu, navigate to FX and then Cascade to Niagara Converter plugin, and enable the plugin. When prompted, click Restart Now for our changes to take effect. Convert our desired Cascade particle systems to a Niagara system by right-clicking on a Cascade particle in the content browser and selecting Convert to Niagara System from the context menu. A new Niagara system is created in the same directory as the source Cascade system with the suffix converted. Once the Unreal Engine editor has restarted, when we right-click in the content browser, we will have a new FX section that will have all of the various items we can use with Niagara. A commonly used visual effects technique that is rendered is called sprites. In this video, we will set up a Niagara emitter to work with sprites. When we place the Niagara system containing the Niagara emitter into a level, we will see the effect displayed in that level. However, we have some prerequisites for this. We need the m_smoke_sub-UV material, which can be found with the starter content. If we have not done so already, make sure that this material or the starter content has been added to our project. First, make a new folder in the content browser to hold the assets for our effect. Let's see the recommended workflow is to create a system from existing emitters or emitter templates. First, create a Niagara system by right-clicking in the content browser, and from the displayed menu select FX and then Niagara System. The Niagara System wizard displays. Select New System from selected emitters. Then click Next. Under Template, select Simple Sprite Burst. Click the plus sign icon to add the emitter to the list of emitters to add to the system. Then click Finish. Name the new system Smoke System. Double-click to open it in the Niagara editor. The emitter instance in our new system has the default name of Simple Sprite Burst. We can rename it, however. Click the name of the emitter instance in the system overview, and the field will become editable. This video, we will go through the emitter module groups as they appear in the stack. However, until we set our material in the renderer, we won't see anything in our preview or in our level. So first, in the system overview, select the sprite renderer to open it in the selection panel. This is where we select the material for our effect. Since the material is a sub-UV material, we need to tell the renderer how many images are in the image grid. Set the following properties to some certain values. Now we will edit the emitter update group settings. First, we will edit the modules in the emitter update group. These are behaviors that apply to the emitter and that update each frame. Here we want to create a constant column of smoke, not a burst of smoke. Click the trash can icon to delete the spawn burst instantaneous module. Now add the spawn rate module to the emitter update group by clicking the plus sign icon and selecting spawning and then spawn rate. Then in the spawn rate module, set the spawn rate to 50. This will give us a good-sized puffy shape made of smoke. This is a good start to our effect. For now, while we are building the effect, we want to set the simulation to run on an infinite loop. This gives us more time to evaluate how the settings are affecting the effect. In the emitter state module, click the drop-down for life cycle mode and select self. Then click the drop-down for loop behavior and select infinite. Now we will do the particle spawn group settings next. We will edit the modules in the particle spawn group. These are behaviors that apply to particles when they first spawn. In the system overview, click the particle spawn group to open it in the selection panel. First, expand the initialize particle module. This module collects several related parameters together in one module, minimizing clutter in our stack. Under point attributes, locate the lifetime parameter. The lifetime parameter determines how long particles will display before they disappear. Here we want a little randomness in the lifetime parameter to better simulate real smoke. Click the drop-down arrow next to lifetime and select dynamic inputs and then random range float. This adds minimum and maximum fields. Now set the lifetime minimum and maximum to the following values. Minimum 2, maximum 3. We are going to adjust the size of the sprite particles to continue making the smoke effect more realistic. The original bundle of particles is rather small, so we are now going to increase the size. We will also make the size a little random, so the sprite particles overlap and make a more consistent smoke effect. Under sprite attributes, locate the sprite size parameter and make sure it is enabled. Click the drop-down arrow next to sprite size and select dynamic inputs and then vector 2D from float. This replaces the sprite size X and Y fields with a single value field. Next we need to add another dynamic input to add randomness. Click the drop-down arrow next to value and type random in the search bar. Select random range float. This adds minimum and maximum fields to the value. Now set the minimum and maximum values for sprite size as minimum 75, maximum 200. So now we have a larger mass of smoke. Our result is getting closer to looking real. Now we are going to add some rotation to add more variation to the particle's shape. Additionally, we will add randomness to the rotation to increase the variation. Set the drop-down next to sprite rotation mode to direct normalized angle, that is 0 to 1. Next, click the downward arrow next to sprite rotation angle and select dynamic inputs and then normalized angle to degrees. This adds a normalized angle field. This means the rotation angle in degrees is converted to a decimal between 0 and 1. Now click the drop-down arrow next to normalized angle and select dynamic inputs and then random range float. This adds minimum and maximum fields to the normalized angle. The particles will rotate a random number of degrees when they spawn. Set the minimum and maximum values as minimum 1, maximum 2. So now we have a fairly good size cloud of smoke, but it is just spinning in place. We want the smoke particles to start moving as soon as they spawn. So now we will add some initial velocity. Add the add velocity module to the particle spawn group by clicking the plus sign icon and selecting velocity and then add velocity. Now click the drop-down arrow next to velocity and select dynamic inputs and then random range vector. This adds minimum and maximum fields to the velocity. Again, the slight randomness adds variation and naturalness to the effect. Set the velocity minimum and maximum values as minimum 0 to x and y and 50 to z and maximum x1, y1, and z 200. Sphere location controls the shape and origin of where sprites spawn. By adding a sphere location module, we can have the sprite spawn in a sphere shape and we can set a radius to determine the size. Add the sphere location module to the particle spawn section by clicking the plus sign icon and selecting location and then sphere location. Set the sphere radius to 64. Make sure the sphere distribution is set to random. The sprite material that we are using for this smoke effect uses a sprite sheet, which has multiple images that are designed to be strung together and animated. When we do not account for this, our renderer will only use the first sprite on the sheet. We can add a sub-UV animation module to solve this problem. Click the plus sign icon for particle spawn and select sub-UV and then sub-UV animation. In the sub-UV animation module, click the drop-down for sub-UV animation mode and select linear. For number of frames, type 64. The sprite sheet has an 8x8 grid of images, so the total number of images is 64. Now see the particle update group settings. Here we will edit the modules in the particle update group. These behaviors apply to particles and update each frame. The velocity we added in particle spawn gave our particles some movement when they initially spawn. Now we want to add movement over time, and we want the smoke to rise. Add the acceleration force module by clicking the plus sign icon for particle update and selecting forces and then acceleration force. Because Niagara adds new modules to the bottom of the group stack, we will get an error stating, the module has unmet dependencies. That is because the acceleration force module was placed after the solve forces and velocity module. Click the Fix Issue button to move the module. Leave the X and Y values set to 0 and the Z value to 500. This will give the smoke significant upward movement over time. We can adjust this setting or even remove this module depending on the type of smoke effect we want to create. If we want to be able to reuse the smoke emitter in our system, we can save it as a separate asset. Click the gear icon to open the emitter settings menu and select Create Asset from this. The result is an independent Niagara emitter asset. Then click the Save button to apply and save the changes. So, here is a simple smoke effect using sprites. Now let's drag the Niagara system onto the level. Here we are. When you make a particle effect, it is always a good idea to drag your system into your level. This gives you a chance to see every change and edit in context. Any changes you make to the system automatically propagate to the instance of the system at your level. Great. We have created a simple smoke effect using sprites. In the earlier video, we have seen how the Niagara system can be plugged in and make of simple sprite emitters in CPU, in the form of smoke. For some effects, you may need to spawn tens of thousands of particles. However, using the standard CPU to generate this many particles can cause performance issues. In this video, we will show you how to create a sprite particle effect that uses the GPU instead of the CPU to run the simulation. So let's start. First, create the system and emitter. Niagara emitters and systems are independent. The current recommended workflow is to create a system from existing emitters or emitter templates. First, create a Niagara system by right-clicking in the content browser, and from the displayed menu select FX and then Niagara system. The Niagara system wizard displays. Then select New System from selected emitters. Then click Next. Under Templates, select Simple Sprite Burst. Click the plus icon to add the emitter to the list of emitters to add to the system. Then click Finish. Name the new system GPU Sprite. Double-click to open it in the Niagara editor. The emitter instance in your new system has the default name of Simple Sprite Burst, but you can rename it. Click the name of the emitter instance in the system overview and the field will become editable. Drag the GPU Sprite system into your level. When you make a particle effect, it is always a good idea to drag your system into your level. This gives you a chance to see every change and edit in context. Any changes you make to the system automatically propagate to the instance of the system in your level. Now let's see how we can modify the emitter settings. First, you need to change some settings in the emitter properties. This is where you switch from CPU simulation to GPU simulation. In the system overview, click Emitter Settings to open it in the selection panel. And then expand Emitter Properties. Locate the Sim Target field. This is where you tell Unreal Engine to use the GPU for the simulation. Click the drop-down and select GPU Compute Sim. Now you may trigger a warning about the fixed bounds not being set. Click the box for fixed bounds. This will resolve the error. Leave the minimum and maximum set to the default values. Because the particle simulation is done on the GPU, the system cannot read how big the effect is. This is why it is necessary to set fixed bounds. You can set fixed bounds for the entire system in the System Properties item. Now let's update the emitter group settings. You will edit the modules in the emitter update group. These are behaviors that apply to the emitter and that update each frame. First, in the system overview, click Emitter Update to open it in the selection panel. First, expand the emitter state module. This module controls time and scalability for this emitter. Because you used the Simple Sprite Burst template, the life cycle mode is set to self. Normally this is used for complete customization of emitter lifecycle logic for this specific emitter, but it is not needed for this effect. Now click the drop down and set the lifecycle mode to System. This enables your system to calculate the life cycle settings, which usually optimizes performance. By default, the system loops infinitely on a 5-second interval. The Spawn Burst Instantaneous module creates a large burst of particles when the emitter spawns. This module is included in the Simple Sprite Burst template. Set the spawn count to 2500. Because spawn time is set to 0, the burst occurs immediately upon startup. For this effect, you need more than just a burst of particles when the emitter spawns. The spawn rate module creates a continuous stream of particles while the emitter is active. Add the spawn rate module by clicking the plus sign icon for emitter update and selecting spawning, and then spawn rate. Set the spawn rate to 500. This will spawn particles at the rate of 500 per second, which will provide a continuous stream of particles after the initial burst. Now modify the particle spawn group settings. Here, you will edit the modules in the particle spawn group. These are behaviors that apply to particles when they first spawn. In the system overview, click Particle Spawn to open it in the selection panel. Expand the Initialize Particle module. This module collects several related parameters together in one module, minimizing clutter in your stack. Under Point Attributes, locate the Lifetime parameter. The lifetime parameter determines how long particles will display before they disappear. For this effect you want a constant value, so that the particles will display for the entire duration of the effect. Set the lifetime to 5. You will make the sprite size randomized in another part of this guide, but here we will set the base size of the sprite. Under Sprite Attributes, locate the sprite size parameter and make sure it is enabled. Set the sprite size to X as 5, and Y as 5. Sphere location controls the shape of the location where sprites spawn. By adding the sphere location module, the sprites spawn in a sphere shape, and you can set the size of the sphere shape by indicating a radius. Add the sphere location module by clicking the plus sign icon for particle spawn and selecting location and then sphere location. You can leave the default settings for this module. Now modify the particle update group settings. Here you will edit the modules in the particle update group. These behaviors apply to an emitter's particles and update each frame. In the system overview, click the particle update group to open it in the selection panel. In the Initialize Particle module of the particle spawn group, you picked the base size of the sprites. You can randomize the size of the sprites by adding the Scale Sprite Size module. This applies a scaling factor to the base size. Add the Scale Sprite Size module by clicking the plus sign icon and selecting Size and then Scale Sprite Size. The default values for Scale Sprite Size are X is 1 and Y is 1. Changing these default values will uniformly make all the particles bigger or smaller. However, random size variation is more visually interesting than a static size. Click the downward arrow next to the scale factor field, and select dynamic inputs and then vector 2D from float. Notice that the value for scale factor has changed to one static value. There are several ways to add a float value, depending on what you want the particles to look like. For a flowing and gradual size change, a curve is ideal. Click the downward arrow next to value and select dynamic inputs and then float from curve. The curve you added has two default values. You can add more keys to the curve to make the size variation more complex. Right-click on the line and select Add Key to Curve. Do this again, so that you have a total of 4 keys displaying on the curve. Set the 4 keys on the curve to the different values. Key number first, time 0, and value 0. Then key number second, time 0.25, and value 1. Then key number third, time 0.75, and value 1. And lastly key number fourth, time 1, and value 0. Right now, your current settings just create a ball of particles that is not very interesting. You can add some additional elements that increase the variation and movement of the particles. Click the plus sign icon for particle update, and select forces and then curl noise force. There are a lot of things you can do with curl noise force. Noise strength controls how large the overall noise field is. In other words, how much the noise disrupts the original sphere of particles. Noise frequency controls how often the curl noise is applied to the particles. The smaller the number, the more warped the sphere location of the particles will become. Change the settings for now, but later you can experiment with these to get a different look. Noise strength is 72 and noise frequency is 0.02. Now you will see that the particles swirl at first, then just move outward continuously until they die. For this effect, the particles should move outward and then back in toward their origin point, to make a swirling mass. The Point Attraction Force module makes the particles move toward a single point. By default, this point is the emitter's position. Click the plus sign icon, plus, for particle update, and select forces and then Point Attraction Force. Attraction strength is the amount of force pulling the particles to the attractor point. Attraction radius delineates the size of the field in which the point attraction force applies to the particles. The fall-off exponent controls how much the sphere spreads. The smaller the number, the more the sphere of particles spreads out. The kill radius sets the size of the area where the particles dissolve at the end of their life cycle. Click the triangle at the bottom of the module to display the kill radius parameter. Check the box to enable it, if it is not already checked. Now set attraction strength as 5.5. And attraction radius as 300. fall-off exponent is 0.6. And kill radius is 4. Now for changing the color. Click the plus sign icon for particle update and select colors and then color. You can add a color stop to the curve by clicking the space above the colored bar, and you can change the color by double-clicking a stop to open the color picker. To set an opacity stop, click in the space below the bar. Set the colors and opacity as shown below. Congratulations! You've created a cool sprite effect that uses the GPU instead of the CPU. In the earlier videos in this series, we have seen the making of simple sprite emitters in CPU and in GPU. In this video we will see static meshes in some balloons flying. So let's start. Spawning a static mesh instead of a camera-facing sprite can increase the realism of the effects you are creating. In this video, we will show how to set up a Niagara emitter to spawn static meshes instead of sprites. Let's see what are the prerequisites. In this video we will use the shape_sphere static mesh, which is found with the starter content. If you have not done so already, make sure that the static mesh or the starter content has been added to your project. First, start with creating a material for mesh. The effect in this video is meant to look like a cloud of balloons being released. To enhance this effect, you will make a simple material that makes the mesh look like a rubber balloon. Right-click in the content browser and under Create Basic Asset select Material. Name the new material Alloon. Double-click it to open in the material editor. In the palette panel, type particle in the search bar. Select particle color and drag it into the graph to add a particle color node. Drag off the RGB output and connect the wire to the base color input on the material node. While holding down the 1 key, click in the graph. This creates a constant node. Copy and paste it twice for a total of 3 constant nodes. Connect the output on one constant node to the metallic input on the material node. You can set the value of a selected constant in the Details panel under Material Expression Constant. This material is not metallic, so leave the metallic constant's value at 0. Connect the output on the second constant node to the specular input on the material node. With the specular constant node selected, set the specular value in the Details panel to 0.7. This will give the material a slightly reflective surface. Connect the output on the third constant node to the roughness input on the material node. With the roughness constant node selected, set the roughness value in the Details panel to 0.2. This will create a mostly smooth surface. Your final result for the material should look like this. Now let's create the Niagara system in Emitter. Niagara emitters and systems are independent. The current recommended workflow is to create a system from existing emitters or emitter templates. First, create a Niagara system by right-clicking in the content browser and selecting FX and then Niagara system. The Niagara emitter wizard displays. Select New System from selected emitters. Then click Next. Under Templates, select Fountain. Click the plus sign icon to add the emitter to the list of emitters to add to the system. Then click Finish. Name the new system Mesh System. Double-click to open it in the Niagara editor. The emitter instance in your new system has the default name of Fountain, but you can rename it. Click the name of the emitter instance in the system overview and the field will become editable. Name the emitter Ash. Now change the renderer. The render group is last in the stack, but you need to change some things so that the effect displays the way it is supposed to. In this case, the template contains a sprite renderer, and this effect needs a mesh renderer. In the system overview, click Render to open it in the selection panel. To make a mesh particle effect you need a mesh renderer module, but the template has a sprite renderer module. Click the trash can icon to delete the sprite renderer. Click the plus sign icon for render and select mesh renderer. Click the drop-down for particle mesh and select shape_sphere. The sphere shape used in this effect has a default material applied to it. By enabling override materials, you can use the custom material you created instead. Click to enable override materials, then click the plus sign icon to add an element to the array. Click the drop-down for explicit matte and select Alloon. Edit emitter update group settings. First, you will edit the modules in the emitter update group. These are behaviors that apply to the emitter and that update each frame. In the system overview, click the emitter update group to open it in the selection panel. Expand the emitter state module. Because you used the fountain template, the life cycle mode is set to self. Click the drop down and set the life cycle mode to system. This enables your system to calculate the life cycle settings, which usually optimizes performance. The spawn rate module creates a continuous stream of particles while the emitter is active. This module is already present in the fountain template. Set the spawn rate to 100. Now edit particle spawn group settings. Next, you will edit the modules in the particle spawn group. These are behaviors that apply to particles when they first spawn. In the system overview, click the particle spawn group to open it in the selection panel. Expand the initialize particle module. This module collects several related parameters together in one module, minimizing clutter in your stack. Under point attributes, locate the lifetime parameter. This parameter determines how long particles will display before they disappear. For this effect, you will use a dynamic input called random range float to randomize how long the particles display. Random range float is already applied to the lifetime parameter in the fountain template. Set the minimum and maximum values as minimum 2 and maximum as 4. Locate the color parameter. Change the RGB values to the following. The material you made in the create a material section has no color designated inside it. To make the mesh particle look like a balloon, you have to set a color. There are modules that can change the color in various ways in the particle update group, but for this effect a solid color is simpler and works fine. Do the setting as red 0, green 0, blue 1. Under sprite attributes, set sprite size mode, sprite rotation mode, and sprite UV mode to unset. Since you are using a mesh, these attributes are not needed for this effect. The original sphere mesh is pretty large, so it looks better for our effect if we make it significantly smaller. Under mesh attributes, set mesh scale to non-uniform. Set the x, y and z values to 0.2. The add velocity module will give the particles movement as soon as they spawn. Add the add velocity module to the particle spawn section by clicking the plus sign icon and selecting velocity and then add velocity. Because this effect is meant to look like balloons being released, some randomness to the speed of the particles is needed. Click the downward arrow next to the velocity value fields, and select dynamic inputs and then random range vector. This spreads out the particles and gives them a small amount of movement on the x, y, and z axes. Now set the velocity minimum and maximum values. This gives the effect a small amount of movement on the x and y axis, and a larger amount of movement on the z axis. Minimum is x, 15, y, 25, z, 50. And maximum is x, 30, y, 30, z, 100. The sphere location module controls the shape of the location where sprites spawn. You can have the sprite spawn in a sphere shape, and you can set the size of the sphere shape by indicating a radius. Set the sphere radius to 200. This spreads the particles out more, as balloons would do when released. Drag your mesh system into your level. When you make a particle effect, it is always a good idea to drag your system into a level. This gives you a chance to see every change and edit in context. Any changes you make to the system automatically propagate to the instance of the system in your level. Now you will edit the modules in the particle update group. These behaviors apply to an emitter's particles and update each frame. In the system overview, click the particle update group to open it in the selection panel. Typically, you would use the gravity force module to simulate how gravity affects objects. You can also use it more generally to add acceleration to your particles. Set the gravity force x, y and z values. X as 10, y as 10, and z as 40. The drag module applies drag to the particles, which slows them down. Set the drag to 1.0. The scale color module is part of the fountain template, but this effect does not require it. Click the trash can icon to remove the scale color module. Congratulations! You've made a mesh particle effect in Niagara. This effect is meant to simulate a big cloud of balloons being released, but it uses a very simple mesh and material. You can get a more realistic look by replacing the simple mesh and material with more detailed meshes and materials. However, you can still bring some colorful changes into it by adding some colors. Go to Initialize Particles and then to Color Mode. Then click the drop down on Color and say, 8 Random Range Linear Color. Repeat the same for minimum and then maximum, and then select the different colors. Your module should look like this. And you will have multiple colors balance. In the earlier videos in this series, we have seen the making of static mesh as in some balloons flying. In this video, we will take a look at setting up a Niagara emitter so that particles and lights are spawned at the same time. So let's start. When you give particles the ability to illuminate the world around them, it can add an extra layer of realism to any of your project's visual effects. We have some prerequisites. In this video, we will use the ideal_gradient material, which is found with the starter content. You should create a new project that includes the starter content, or use a project that was created with starter content included. First, create the system and emitter. Niagara emitters and systems are independent. The current recommended workflow is to create a system from existing emitters or emitter templates. First, create a Niagara system by right-clicking in the content browser, and from the displayed menu select FX and then Niagara system. The Niagara emitter wizard displays. Select the Create System menu. Now select New System from selected emitters, then click Next. Now open System Wizard. Under Templates, select Fountain. Select Fountain Template. Click the plus sign icon to add the emitter to the list of emitters to add to the system, then click Finish. Name the new system as Particle Light. Double-click to open it in the Niagara editor. The emitter instance in your new system has the default name of Fountain. You can rename it, however. Click the name of the emitter instance in the system overview, and the field will become editable. Name the emitter Particle Light. Now drag your particle light system into your level. When you make a particle effect, it is always a good idea to drag your system into a level. This gives you a chance to see every change and edit in context. Any changes you make to the system automatically propagate to the instance of the system in your level. Now edit the emitter update group settings. First, you will edit the modules in the emitter update group. These are behaviors that apply to the emitter and that update each frame. In the system overview, click the emitter update group to open it in the selection panel. Open emitter update group. Expand the emitter state module. Because you used the fountain template, the life cycle mode is set to self. Click the drop down and set the life cycle mode to system. This enables your system to calculate the life cycle settings, which usually optimizes performance. So set life cycle mode. The spawn rate module creates a continuous stream of particles while the emitter is active. This module is already present in the fountain template. Set the spawn rate to 500. Now edit the particle spawn group settings. Here you will edit the modules in the particle spawn group. These are behaviors that apply to particles when they first spawn. In the system overview, click the particle spawn group to open it in the selection panel. Open particle spawn group. Expand the initialize particle module. This module collects several related parameters together in one module, minimizing clutter in your stack. Under point attributes, locate the lifetime mode drop down and set to random. This parameter determines how long particles will display before they disappear. For this effect, you will use a dynamic input called random ranged float to randomize how long the particles display. Random ranged float is already applied to the lifetime parameter in the fountain template. Set the minimum and maximum values as minimum 1.75 and maximum 2.5. Also under point attributes, locate the color parameter. This sets the initial color of the particles when they spawn. Set the RGB fields. The Unreal Engine color picker normalizes RGB color values to an integer between 0 and 1. However, if you set a color value greater than 1, it becomes a emissive color. The particles will glow that color when the system is placed in the level. Red is 0.1. Green is 0.50. Blue is 0.1. Under Sprite Attributes, locate the sprite size parameter and check the box to enable it. To add some randomness to the size of the fountain particles, adjust the sprite size mode. Click on the drop-down menu and select Random Uniform. This adds minimum and maximum fields to the value. Set the sprite size minimum and maximum values as minimum 2.5 and maximum 8.0. Sphere location controls the shape and origin of where sprites spawn. You can set the size of the sphere shape by indicating a radius. The sphere location module is included in the fountain template. Set the sphere radius to 15. The fountain template also contains the add velocity in cone module. This adds movement to the particles when they spawn. The point of the cone is at the particle spawn point, and you can set x, y, and z values to determine in which direction the cone expands. The velocity strength has a dynamic input called random ranged float applied. Now set the minimum and maximum values, and leave the other settings at their default values. Minimum is 300, and maximum is 600. Now you will edit the modules in the particle update group. These behaviors apply to an emitter's particles and update each frame. In the system overview, click the particle update group to open it in the selection panel. The gravity force module simulates how gravity affects objects. The drag module applies drag to the particles, which slows them down. The default settings for gravity force and drag work for this effect, so you can leave them that way. Without setting up a collision, the particles in your effect will just fall through the floor or any other solid objects on the level. To add a collision module, click the plus sign icon for particle update and then select collision, and then finally again collision. This adds collision module. The collision module is inserted at the bottom of the stack, after the solve forces and velocity module. This causes an error. Click Fix Issue to move the collision module and resolve the error. Leave the default settings for the collision module in place. Now you will add the light renderer to the fountain effect. In the system overview, click the render group to open it in the selection panel. Click the plus sign icon for render, and select light renderer. Set the radius scale to 5.0. This determines how far from the particle spawn point the light spreads. So do light renderer settings. The color add values enable you to change the color of the light emitted by the effect. These values are labeled with X, Y, and Z. However, they correspond to RGB values, with X equals red, Y equals green, and Z equals blue. To match the light color with the particle color, set the values. Red is 0, green is 15, and blue is 0. Congratulations! You have created an effect that includes a particle light, and that emits light in your scene. In the earlier videos in this series, we have seen the making of simple sprite emitter and adding light effects onto it. In this video, you will learn how to set up a Niagara emitter to emit a continuous ribbon-style particle. So let's start. Simulating natural phenomena is challenging, especially when using sprite or mesh-based particles to simulate smoke or vapor trails. Ribbon emitters are an excellent solution for simulating these objects. First, create system and emitter. Unlike in Cascade, Niagara emitters in systems are independent. The current recommended workflow is to create a system from existing emitters or emitter templates. First, create a Niagara system by right-clicking in the content browser, and selecting FX and then Niagara system. The Niagara emitter wizard displays. Select New System from selected emitters. Then click Next. Under Templates, select Simple Sprite Burst. Using a template will place an emitter instance in your new system, and that emitter instance will have no inheritance. Click the plus sign icon to add the selected emitter to the list of emitters to add to the system. Then click Finish. Name the new system Ribbon System. Double-click to open it in the Niagara editor. The emitter instance in your new system has the default name of Simple Sprite Burst, but you can rename it. Click the name of the emitter instance in the system overview, and the field will become editable. Name the emitter Eben. Now change renderer. The render group is last in the stack, but you need to change some things so that the effect displays the way it is supposed to. The original template used a sprite renderer, but this effect needs a ribbon renderer. In the system overview, click Render to open it in the selection panel. To make a ribbon effect, you need a ribbon renderer module. But the template has a sprite renderer module. Click the trash can icon to delete the sprite renderer. Click the plus sign icon for render and select ribbon renderer. The material you want is not displayed by default. Click the drop-down for material, and click View Options to open a list of options. Check the boxes for Show Engine Content and Show Plugin Content. Now you will be able to see the material. Click the drop-down for material and select Default Ribbon Material. If you completed the Create a Mesh Particle Effect how-to, you can select the Alloon material instead. This will give you an opaque ribbon, rather than the translucent one created by the default ribbon material. Now edit the emitter update group settings. First, you will edit the modules in the emitter update group. These are behaviors that apply to the emitter, and that update each frame. Even after adding a ribbon renderer and editing the settings in the emitter update group, you will not see a ribbon appear. This is normal. When you get to the particle spawn section of this document, you will start to see the actual ribbon. In the system overview, click the emitter update group to open it in the selection panel. Expand the emitter state module. This module controls time and scalability for this emitter. Because you used the simple sprite burst template, the lifecycle mode is set to self. Normally this is used for complete customization of emitter lifecycle logic for this specific emitter, but it is not needed for this effect. Click the drop-down and set the lifecycle mode to system. This enables your system to calculate lifecycle settings, which usually optimizes performance. By default, the system loops infinitely on a 5-second interval. The spawn rate module creates a continuous stream of particles while the emitter is active. Add the spawn rate module by clicking the plus sign icon for emitter update and selecting spawning and then spawn rate. Set the spawn rate to 100. Edit the modules in the particle spawn group. These are behaviors that apply to particles when they first spawn. In the system overview, click the particle spawn group to open it in the selection panel. Expand the initialize particle module. Click the trash can icon to delete it. You do not need this module, because there is a different module for initializing ribbons. The initialize ribbon module performs a similar function to initialize particle, in that it collects several parameters into one module. Click the plus sign icon for particle spawn and select initialize and then initialize ribbon. Under point attributes, locate the lifetime parameter. This parameter determines how long particles will display before they disappear. Set the lifetime to 5. Set the mass parameter to 10. This will affect how the ribbon spreads outward, as well as how quickly it falls. For the color parameter, set the red value to 1. Leave the other values at 0. You can change the color later if you choose. Under ribbon attributes, set the ribbon width to 10. To make the ribbon spin in a spiral, you can add a torus location module. Location modules affect the shape of the location where the particles spawn. Click the plus sign icon for particle spawn and select location and then torus location. Under shape, click the drop-down for torus mode and select ring. Set the large radius to 50. The large radius determines how large the primary ring shape is. Under distribution, click the drop-down for torus distribution mode and select direct. The U position parameter sets the position on the ring shape. Expand the emitter attributes section of the parameters panel. Drag the emitter age parameter over to the selection panel. You will see green dotted lines around the fields where you can use that parameter. Drop the emitter age parameter on the U position value. Your ribbon will look like it is spinning in a static ring, but you will change that in the next step. Now you will add some velocity to the ribbon. Click the plus sign icon for particle spawn and select velocity, and then add velocity from point. Set the velocity strength to 50. Now you will see the ribbon start to spiral. This happens because as the position is moving around the large radius, the velocity pushes the ribbon outward from the original ring. Now you will edit the modules in the particle update group. These behaviors apply to an emitter's particles and update each frame. In the system overview, click the particle update group to open it in the selection panel. This effect has a single color, so the scale color module is not needed. Click the trash can icon to delete it. Add the acceleration force module. This is what makes the spiraling ribbon fall down, simulating gravity. Click the plus sign icon, plus, for particle update and select forces and then acceleration force. Because Niagara adds new modules to the bottom of the group stack, you will get an error stating, the module has unmet dependencies. That is because the acceleration force module was placed after the solve forces and velocity module. Click the fix issue button to reposition the module and resolve the error. Set the Z value of the acceleration to -200. A positive Z value would make the ribbon spiral upwards. Using a negative value makes it drop downward in a parabolic shape. Congratulations! You have created a Niagara ribbon effect. In the earlier videos in this series, we have seen the making of a Niagara emitter to emit a continuous ribbon-style particle effect into the world. So let's start. In Niagara, the ribbon renderer is used along with specific modules that indicate that the ribbon is being used as a beam. In this video, you will learn how to create a beam that simulates lightning. First, create system and emitter. In Niagara, systems and emitters are independent. The current recommended workflow is to create a system from existing emitters or emitter templates. First, create a Niagara system by right-clicking in the content browser and selecting FX and then Niagara system. The Niagara emitter wizard displays. Select New System from selected emitters. Then click Next. Under Templates, select Static Beam. Click the plus sign icon to add the emitter to the list of emitters to add to the system. Then click Finish. Name the new system Beam System. Double-click to open it in the Niagara editor. The emitter instance in your new system has the default name of Static Beam, but you can rename it. Click the name of the emitter instance in the system overview and the field will become editable. Name the emitter EAM. Now change the renderer settings. The render group is last in the stack, but you need to change some things so that the effect displays the way it is supposed to. In the system overview, click Render to open it in the selection panel. The emitter template in this system already has a ribbon renderer included. You will add specific modules later in this guide to indicate that the ribbon is used as a beam. The material used for this renderer is the default ribbon material. If you scroll past the settings in the ribbon rendering section, you will find a section called Tessellation. In that section, set the curve tension to 0.5. This will affect how spiky the lightning effect is. You can raise or lower that value to vary your effect. Now edit the emitter update group settings. First, you will edit the modules in the emitter update group. These are behaviors that apply to the emitter and that update each frame. In the system overview, click the emitter update group to open it in the selection panel. The static beam emitter template has the life cycle mode set to self by default. This means the life cycle and loop behavior of the emitter is set directly, instead of being handled by the system. For this effect, you will add some randomness to the loop duration by adding a float to the value. Click the drop-down arrow for loop duration, and select dynamic inputs and then random ranged float. This adds minimum and maximum fields under loop duration. Set the loop duration minimum and maximum value as minimum 0.1 and maximum 0.2. The first module that indicates this effect uses a beam is the beam emitter setup module. Since you started with the static beam template, this module is already included. For beam start and beam end, we have to do some alteration. Check the boxes to enable absolute start and absolute end. The start position of the beam is defined by the position of the Niagara system in the scene. Drag your beam system into your level. When you make a particle effect, it is always a good idea to drag your system into a level. This gives you a chance to see every change and edit in context. Any changes you make to the system automatically propagate to the instance of the system in your level. The end position is defined by the static coordinates set in beam end. Let's copy the stimulation position and add some difference in y direction, say around 600 from the original position. To add an arc or curve to the effect, check the box to enable use beam tangents. This displays the beam start tangent and beam end tangent settings. Click the reset to default, that is the small yellow arrow icon for beam start tangent, to change the value to multiply vector by float. The beam end tangent is already set to multiple vectors by float. Set the beam start tangent vector and float values. X is 0, Y is 0 and Z is 1. And finally float is 0.5. Now set the beam end tangent vector and float to the following values. X is 0, Y is 0 and Z is 1. And finally float is 1. You need to understand how the tangent values at different directions alters the shape of beam arch. We would recommend you to do these alterations so that you can understand the tools in better manner. In the spawn burst instantaneous module, set the spawn count to 35. Here again you can check the effects of various inputs in spawn counts. Edit the particle spawn group settings next. You will edit the modules in the particle spawn group. These are behaviors that apply to particles when they first spawn. In the system overview, click the particle spawn group to open it in the selection panel. In the initialize particle module, locate the lifetime parameter. This parameter determines how long particles will display before they disappear. Set the lifetime to 0.2. This short lifetime will cause the beam to flicker, which will make the lightning more realistic. The spawn beam module is the second beam specific module. You do not need to set anything with this module, it just needs to be present. The third beam specific module is the beam width module. The beam width is set to float from curve. Click the second curve key to display the time and value fields. Set the time to 0.5 and the value to 1. To make the shape look right, right-click each curve key and make sure it is set to auto. Below the curve diagram you will see some additional settings. Set the scale curve to 5. So based on your requirement you can choose the figure. Check the scale curve value, how it modulates the beam, and put the figure as per your requirement. Now edit the particle update group settings. Here you will edit the modules in the particle update group. These behaviors apply to an emitter's particles and update each frame. In the system overview, click the particle update group to open it in the selection panel. In the color module, set the RGB values. R as 0.1, G as 1 and B as 0.1. To break up the curve and make the beam crackle and jump like lightning, add the jitter position module by clicking the plus sign icon for particle update and selecting location and then jitter position. To make the jitter position module work correctly, you need an update beam module. Add the update beam module by clicking the plus sign icon for particle update and selecting beam and then update beam. In the system overview, drag the update beam module to a position above the jitter position module in the stack. Now go back to the jitter position module. The default setting for jitter amount is 10, and the default for jitter delay is 0.25. However, if you decrease the jitter delay to 0.1 you will start to see the beam bend with an angular, jagged motion. With the value at 0.1 you can still see the original arc shape under the jagged beam, which is not ideal. To fix this, you have to set the jitter delay to a negative number. Set the jitter delay to -0.01. Set the jitter amount to 15. Congratulations! You have created a beam effect that simulates lightning. You can use beams for all kinds of visual effects, lasers, weapon rays, Tesla coils and so on. You can experiment with colors here. We have added some colors to give a multiple color effect through the color curve. What you have to do is go to the particle update module, and then click on group down near colors, then dynamic inputs and choose color curve. In the earlier videos in this series, we have seen the making of a Niagara emitter to emit a continuous spark particle effect into the world. So let's start. Create a Niagara system, a simple sprite will do. OK, select fountain, so that we have a ready-made system. Name it fx_spline. Open the fx_spline system, so the basic material looks like this. And the go to emitter update, set loop behavior to infinite, and then to spawn rate, let it be 90. Now this spawning, however, this doesn't matter now as you will create a spline where the spawning particles will follow the path of the spline. Now go to particle spawn system, and open initialize particle, you can set lifetime as maximum as 10, later on based on the length of spline, you can adjust. Now you will create a blueprint class here at the BP_spline. Just open this and add the spline component. Now create some random shape by dragging and adding new spline points. Maybe 7 to 8 spline points you can add. So here we are. Compile this and then go to level and drag the BP_spline onto the level. Also drag the particle system. Now you will make both the blueprint class and Niagara system at same location. For this, copy the location of blueprint and paste it on the particle system. Now both of them are at same position. And you will move spawning particles move along with the spline path. Okay, now we will connect the Niagara system to spline. Now you need a module script, so right click and select FX and Niagara module script. Name it ms_spline. Now double click it and open the module script. Here you will use a spline line, so that the spawning particle should snap to this spline over their edge. In module script, click on the plus sign in the get map node. And then select add existing parameter and the data interface, and finally input new spline. Name the category as spline. Okay, now drag the node and click and search for sample spline position by unit. So here particle should snap to the spline throughout the lifetime. And it should update to particle position. So here I will take a particle position by clicking and search position. You will get particle position, and then just connect position to over here on particle position. Now click on the plus sign on get map node and search for particles normalized edge. Select it and then connect it to U. Now compile it and do back to particle system. You can check on the user parameter. You will see nothing here. Okay, now we will connect the Niagara system to spline. Here you will get into concept of user parameter. Select the Niagara system and go to particle spawn. In particle spawn system, go to color and click on drop down and select make and then select from the user parameter. This will enable you to control the color of the particle spawning. Now click on the user's parameter under system settings. You can see the color parameter here. Now check the same in your level viewport by selecting the Niagara system and find the colors in the user parameter in the details panel. From here also you can change and modify the parameters of this module. You can control these parameters through blueprints also. Okay, for time being delete this. Okay, now we will connect the Niagara system to spline. In the particle update, click on the plus sign and search for spline. In case not visible, deselect the library and search again. And select the ms_spline. And click on the same on the module. You will see the detail panel. Here click on the drop down besides the spline and select user parameter. This enables the user parameter for spline. You can check on the user parameter. You will see the new spline there, which was earlier not there. Now go to the viewport and select the Niagara system, and in detail panel search for override parameters. And add there the BP_ns. You will see the particles spawning along with the spline path. Well, it started. But since we made some changes in color, which made it blank. Okay, let's make the color changes and also some changes in the spline point position. And check. Here this is all 0. Let's add some value to it, which will reflect in terms of color. Congratulations. After following these steps, the spark fountain system in your level, which we originally selected, now follows the path of spline. Just another example, we have made a spline for all display path created in spline. And particles which are spawning follow the same path. In the earlier videos in this series, we have seen the making of a Niagara emitter where the spawning particle follows a certain path created in spline into the world. In this video, you will learn how to attach the Niagara emitters onto mesh, skeletal mesh and an animated skeletal mesh. So let's start. Create a Niagara system. A simple sprite will do. Okay, select directional burst, so that we have a ready-made system. Name it fx_sm. Open so the basic material looks like this. And the go to emitter update, set loop behavior to infinite, and then to spawn burst, let it be 75. Now this spawning, however, this doesn't matter now as you will add mesh, and where the spawning particles will take up the surface. You can adjust the count. And then remove the unnecessary module which is not required for this project. You can set lifetime. Later on, based on your requirement, you can adjust. Do some changes in color. And some alteration in size. Now time to attach mesh. First you will attach a simple mesh and will try with other mesh just to find out the shape of the mesh and how the particles are emitting out of it. Now go to the particle spawn, look for static mesh. Now go to the particle update, there you look for the location and select static mesh location. Now go back to particle spawn and go to preview mesh. Select some mesh, say cube. Repeat the same for default mesh. So now the particles are taking up the shape of mesh. Let's increase the spawn count to make the effect more prominent. Here we are. Now drag the particle system onto level. Okay, now let's try with some other mesh. Go back to particle spawn and go to preview mesh. Select some other mesh, say rock. Repeat the same for default mesh. So the particles have spawned in the shape of the rock. You can increase the particle count to have a more prominent effect. Okay, now create the same effect with skeletal mesh. Create a duplicate of this particle system and name it FXSKM2, and open it. First thing you need to do is delete the static mesh module in the static mesh location module. We don't need it here. Instead add skeletal mesh module in particle spawn, and skeletal mesh location in particle update. Add skeletal mesh module in particle spawn, and skeletal mesh location in particle update. Now go to particle spawn and skeletal mesh module and add any skeletal mesh. The mannequin skeletal mesh is already available in starter content. Select the same. And repeat the same in particle update for skeletal mesh location. Now drag the FXSKM2 onto the level. You can have some dotted structure. Nothing is a mannequin. On looking closer, these are some dotted outlines. So we need to do some changes here in particle spawn. Go down in the skeletal mesh module in particle spawn. Go to mesh sampling and change the setting to surface triangles from skeleton bones. And repeat the same in particle update for skeletal mesh location. Now you can see the complete mannequin is visible and particles are spawning all across the surface randomly. Again, increase the spawn count to make the effect more prominent. Eventually, we are going to want some animation on this. We don't want it just stuck in a T-pose. Now to do this, we are going to need to add the source. Now the source can only come from something in the world outliner, so we really need to be able to access this variable in the details panel in the level. To do that, we are going to make an exposed variable for our skeletal mesh. And then we are going to tie that to the two places where we have a skeletal mesh in update. And then we are going to go ahead and bring that into our level, and then we are also going to bring in animation file. Create another duplicate of the same file and name it fx_skm_anime. And open it. Now check in both the skeletal mesh module source is not highlighted. For animation we need the source to be active. Here we need user exposed. Click on the plus sign and add mesh and select skeletal mesh. Now select the skeletal mesh module and drag the user exposed skeletal mesh onto the skeletal mesh in the module, which will appear as green. Now repeat the same for the particle update module. Now drag the new particle system onto the level. Ignore the orientation. Now select any animation from the starter content. So in the animation file, we need to do two things. First, going to make it invisible because we don't need to see the actual character. We are going to put a bunch of particles on it so we can just hide the animation itself, and before that, we need to always tick pause and refresh bones. And refreshing the bones is what the particle is going to use every time they update the location. Okay, now so start adding animation to this effect. Here we have selected third person run. Drag that also onto the level. Okay, now do some changes in the animated skeletal mesh. Go down in the detail panel and look for optimization. In optimization, select the option always tick pause and refresh bones. Now select the fx_anime on the level and go to override parameters in the detail panel. The preview mesh is taken up as the default skeletal mesh, that is sk_mannequin. Now in source select the third person run animated character. Now you see instead of normal skeletal mesh, particles are spawning on the animated character. However, you can see the animation unless and until you play the level. So let's play it. So here we are. Particles are spawning based on the location of the mesh and are getting updated also. You can add some force or curl noise for better effect. Now let's make the mannequin invisible. And see how this particle system looks. Select the third person and go down, or search visibility. And untick it to make it invisible. So here we are, a complete mannequin is visible in the form of particle spawning. Congratulations, you have created the particle effect on static mesh and the skeletal mesh, and lastly particles effects on the animated skeletal mesh. In the earlier videos in this series, we have learned how to attach the trail Niagara effect on static mesh, skeletal mesh, and animation. In this video, you will see how to create dynamic material in the Niagara system. So let's start. Okay, so start by making the particle system. So here we are in the right folder. Okay, right click, select FX, and then Niagara system. Click on the Niagara system. So name this FX_DM. Double click to open it. Now create a base material, so right click and select material. Name the newly created material as M_DM. DM means dynamic material. Now double click to open this. Now go back to Niagara system. And just go all the way to the bottom where your sprite emitter is in the renderers module. In the sprite emitters, there is the default material. Double click on this material to open it. You can see this material has got lots of nodes, and nodes are connected. So we don't want to touch this material. So close to this we have created our own basic dynamic material. So go back to the dynamic material. What we need is a particle color. Now connect this particle color to the base color. Please don't forget to change the blend mode to translucent or masked. Let's change it to translucent. Now again right click and search for the material parameter. So here we are in the material parameter. What you can see is there is a 4 parameter named as parameter 1, 2, 3 and 4. Now in this material, but most of the parameters are not active. So we need to enable them. Possibly what we have do is to make the blend mode to masked. So now most of these parameters are active. Now you can see this metallic, specular, roughness and emissive color are visible. Now let's do one thing. Let's connect the parameters 1, 2, 3 and 4 to metallic, specular, roughness and emissive color respectively. Now instead of naming it 1, 2, 3 and 4, let's name it M for metallic, S for specular, R for roughness and A for emissive color. So the naming is just for the purpose of illustration. Now save this material and let's go back to the Niagara system. In the Niagara system, go down to Sprite Emitter and delete that. Instead, add a mesh emitter, so that the effects are visible prominently. Select sphere in the mesh, and in the material select the M_DM, which we recently created. Fine, compile and then save it. And let's go back to the level. Here we go back to the content browser and drag that Niagara system onto the level. So here we are, so what you can see, it is still the material is not compiled properly. Anyway, go back to particle update. In the particle update, click on the plus sign and look for dynamic material parameters. So in the dynamic material parameter, what you can see is, there are 4 parameters as MSR, and E, and all are 0 values right now. And we will do the alteration. And we will see the changes. So let me a couple of changes in color. Let me make it a purple metallic ball. Let's delete the other parameters in the module, which are not necessary right now, particularly like gravity and all the other stuff. All of these will have their own effect, but right now for the purpose of this video, they are not required. Okay, I will just add the collisions. And will leave it as it is. Now, here you can see and a couple of collisions. You can play around with these parameters. Okay, now on increasing the value of M, the metallic luster is seen. Specular property gives the plastic sort of effect. Roughness reduces the reflection part. And emissive light makes the mesh glow. Okay, now instead of masked, let me make it translucent. So that you can see their effects also, like opacity, world position, offset. And we can do the permutation combination with these. Just for the sake of more understanding of the concept. Okay, connect the node to the opacity and another to world position offset. Right now, let's change the name, otherwise, it will be confusing. So more you increase the opacity, mesh became more visible, otherwise, it's invisible. Now let me do some changes in this world position offset. Okay, before doing that, let me do some changes in the level in the placement of this Niagara system. So you can see, the moment I change, the emitter actually goes up the direction randomly, which is the number of the Unreal units. It goes far by the number of units. Let me make it stay near, for example, 100. So it will be 100 units far from the original position. If I make a 200 or so, you can see the emitter goes a bit far. So these are the changes, and all about the dynamic parameters, in the Niagara system, and now the question is whether we can do all the stuff in the blueprint and in the level also. So the answer is yes, you can do that also. To do so, you need to add the user parameters to all of the parameters. Click the button beside the parameter in the detail panel and select red from the new user parameter. Repeat the same for the rest of the 3 parameters. Once you are done, compile and save it. Now check in the level, these user parameters are available in the level. From here you can control the parameters and the look of the emitters. So in the case of emissive color, you can add the random float range also to have multiple effects. To do so, go back to the Niagara system. Add dynamic inputs. And the add random range float. So that gives a minimum and maximum range input. You can add the user parameters to these extended parameters, so that these can also be controlled by blueprint and at the level. So congratulations, you have created the Niagara with dynamic material. In the earlier videos in this series, we have learned how to attach the material dynamic parameters in the Niagara effect. In this video, we are going to talk about Niagara basic shapes and their various alterations in Unreal 5. So let's start. We'll right-click Effects and we are going to create a Niagara emitter from a basic template and we will give it the name fx_shapes. Then we'll open it up. Now there are a few adjustments in Windows. There we go, this is all set up and the idea of shapes and surfaces. So that you can spawn particles on a shape or surface. And the way that we can access those in the particle spawn. It may seem deceptive at first. But they're located in location. Now the shapes that we're talking about specifically are box, cone, cylinder, sphere and torus. Now, let's go to particle spawn, and here we are going to look for various shapes and spawning locations. Now select box location, sphere location, cone location and cylinder location. Now delete the unnecessary modules like drag, gravity. So let's start with the box location. Here we are. You can see the particles are spawning in the form of cube. Okay, let's do some modifications to the spawn rate and particle size. Click on the plus sign and that's we're going to go to the emitter update and we're going to add a spawn rate. We are going to set this spawn rate to something like 1000. And then the next thing we want to do is look at initialize particle and in the sprite size mode, we are going to change this to uniform, and we are going to change the size to 5. So the particles are a little bit smaller. Now as an example, if we click on the box location, we should see that, right away all these particles are adhering to the box shape. And let's play with this. We'll see that they're just all spawning within that box shape. If we want to make this more of a rectangle, we can do that. The options that we have available here are quite straightforward, they're quite simple. If we want to offset this, we want to move it away from 0. Now, we are going to look at the sphere location, so we can change the radius. And right away you'll see that the particles adhere to a sphere for the most part. This is kind of similar to the box, right? We can offset it, we can scale it. Below there is non-uniform scale, you can play around with it, and that gives absolutely different noticeable shape. And the sphere orientation, with sphere shape this won't be noticeable, however skewing will give some noticeable effect. Now next is distribution. Now we'll take a look at the sphere hemisphere distribution. But we have hemispheres, so if we want to cut our sphere in half, so we can do that depending on the hemisphere that we want. The next thing that we have is surface and band thickness. If we turn this on, our particles are going to add just to the surface of that sphere. And now we are going to do the cone. So going through the options that we have cone angle. So we can play around with the length and angle. That's simple. And then we have this axis. But we can rotate this. Put it on a weird axis, whatever you want. Point distribution, this is basically whether or not you want it like this, or if you want it with the end cap. So as you move this, you'll see that this is fading away and cutting off the top. Leave that at 0 and then we can also offset this. There is some shaping here. So if we turn on enable wedge, this is going to make a wedge shape, right? So it's not round, it's squared off. And then we also have flattened end caps. Now what's cool about all of the shapes are that you can use parameters and dynamic parameters with it. Even though they're in particle spawn, you can update them. You can animate them with emitter update. So the next option is cylinder. Here it's simple. Height and radius, which can modify the size of the cylinder. And then comes the orientation. Choosing here the X or Y or Z axis can make the cylinder face the respective direction. Then is the hemisphere X and Y, selecting that can give particles emitting that hemisphere and give a half-filled effect. Then comes the lathe profile, a very important tool. Let's see the curve. Here the key point is at the center, which gives a bulging effect in the middle of the cylinder. The more you alter the position of the key point, the bulge moves. The size of the bulge can be determined by the height of the key. The more you add key points, the more you can create the variation in the cylinder. Okay, after cylinder, it is torus. In the torus mode, there are three options: torus, torus knot and ring. All of them have different implications. First, select the torus knot. This looks like this. Ring is flat planar. Now altering the outer radius and inner radius, you can alter the ring size and inner hole size. Torus axis orientation will change the orientation in the local space. Under torus knot, there are helix loop and knot ring loop. Altering increases the number of knots and you can create more complex shape. The last one we want to show here is grid location. It's very simple. You can alter the particle that emits under a certain grid formation. This can be done through dimensions definition and padding per cell. And also in the emitter update, we get automatically the grid formation. Here you can define the particle counts in various dimensions. So there's a lot of options here. There's a lot of flexibility with these shapes. We encourage you to go through and play with these different shapes and try out all options. Hope this video helps you to initiate your journey into the creative world of Niagara. Thanks a lot. See you in the next video.